Outcome 6, Component 2, Part 1. In this video, we are going to talk about adding and subtracting rational expressions. So in order to add or subtract fractions, we must have a common denominator. Oftentimes, this is also known as the least common multiple, or LCM. You could also call this the LCD, which stands for the least common denominator. So before we get into our rational expressions that have x's, we're going to look at just a quick example of adding and subtracting fractions that just have numbers. So our first step, if I'm doing 5 over 6 plus 4 over 9, my first step is to look at the denominators, so 6 and 9, and I want to find the LCM, or the least common multiple of 6 and 9. Now, multiples of 6 I could find by taking 6 times 1, which is 6, 6 times 2, 6 times 3, 6 times 4, and I could just continue on and on and on. I'm going to do the same thing with 9, so 9 times 1 is 9, 9 times 2, 9 times 3, and again I could just keep doing this. The LCM is the lowest number they have in common, so in this case it looks like they both have 18. So my LCM for this is 18. My second step is to multiply the numerator and the denominator of each fraction so that the denominator becomes the LCM. So we decided that the LCM was 18. I have to think about what I should multiply the 6 by in order to make it 18. Well, if I multiplied 6 by 3, it would give me 18. So I'm going to take this 5/6, and I'm going to multiply both the bottom and the top by 3. Now, it's okay that I'm multiplying it by 3 over 3. 3 over 3 is just 1. What's going to happen here is multiplying on the top, or the numerator, gives me 15. Denominator gives me 18. I'm going to do the same thing with my second fraction. So I started with 4 over 9. Again, I'm multiplying by something so that 9 becomes 18. 9 times 2 will give me 18. So I'm going to multiply top and bottom by 2, making it 8 over 18. Step 3 is to add or subtract the numerators. So now that these two fractions have the same denominator, I'm able to combine them together. 15 plus 8 gives me 23. My denominator stays 18. So this right here is my final answer. Okay, now, since this is Algebra 2, we have to make this a little bit harder, right? Can't just work with fractions that have just numbers. So instead, we're going to do this same process with rational expressions, meaning we're going to have some variables involved. So we might have x's, it might be x plus 2, might be x squared plus 2x plus 1. But rational expressions means we're going to have some x's involved, and they're going to be fractions again. Okay, the only difference is, in order to find the common denominator, or the LCM, the first thing that we need to do is factor the denominators. Okay, a special tip here, if you're dealing with a subtraction problem, we recommend changing it to an addition sign and changing the signs of the numerator of the fraction after the sign. You don't have to do this, but it's a great way to keep that negative involved. Oftentimes we drop the negatives on accident, so that's kind of our special tip for subtraction. Okay, let's go ahead and look at example 1. Now the first thing that we want to do is take a look at the denominators, and if we can factor, we want to factor those. Well, x plus 5 and x minus 5 cannot factor, so I don't have to worry about factoring. The next thing that I want to do is find the lowest common multiple, or the least common denominator, between my two fractions. Now in my first denominator I had an x plus 5. That means that the x plus 5 must be a part of my LCM. whatever's in one denominator automatically must be a part of the LCM. The next denominator has x minus 5. That's different than x plus 5, so I'm going to stick that in the LCM as well. Okay, just like we saw in that number example, what we're going to do now is multiply each fraction by whatever it's missing. I'm trying to make this denominator match the LCM. So for just a minute, I'm going to rewrite the fraction that I start with. So I have x plus 10 over x plus 5. And I want this denominator to match the LCM. Well, it already has the x plus 5, so we're good there, but it does not have the x minus 5. So what we're going to do is multiply the top and the bottom by that x minus 5. Now, because this x plus 10 and x plus 5 are binomials, two pieces, I am going to put them in parentheses. Okay, I'm going to rewrite my second fraction, and what we said to do for this special tip was to change this into a plus sign, and I'm going to change both of the signs on this guy, so that's going to make this a negative x and a negative 5. See how I did that? I just changed this middle sign to a plus, and then changed both of these, since they were positive x, positive 5, into a negative x and negative 5. My denominator right now is x minus 5. Now again, in order to add these together, I need this denominator to match the LCM. Right now it has the x minus 5, but I'm noticing that it does not have the x plus 5. So I'm going to multiply. Sorry guys, my dog was barking and going crazy. So we notice it has x minus 5 in the denominator, does not have x plus 5, so we're going to multiply the bottom and the top by x plus 5. Now I don't want to do any canceling out here. I know that the x plus 5s and x minus 5s could cancel, but I don't want to do that because the whole point of multiplying by those extra pieces was to make these two denominators the same. Now they're both x plus 5 and x minus 5. Sure, they're written out of order, but they're the same thing. So now that they have the same denominator, we can combine the numerators just like we did with those numbers. So I'm going to write this right now as x plus 10 times x minus 5 plus negative x minus 5 times x plus 5. I'm just smushing those numerators together using addition. And now this can be one big fraction with the LCM as the denominator. It does not matter if you write it as x minus 5 and then x plus 5. Order doesn't matter when we're multiplying, so either order for that LCM would be fine. My next step is to simplify as much as I can on top. So I'm out of room here, so I'm going to jump up this way. Okay, I'm noticing at first here I have two parentheses right next to each other. They're connected by multiplication. So we're going to double distribute to simplify these first two parentheses. So x times x gives me x squared. X times negative 5 is negative 5x. 10 times x is 10x. 10 times negative 5 is negative 50. Again, on this side, it looks like I have the same kind of thing, double parentheses connected by multiplication, so we'll go ahead and distribute. Negative x times x would give me negative x squared. Negative x times 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times 5 is negative 25. This is still all over my LCM. Now, I know it looks pretty crazy, but from here, all we need to do is simplify, combine like terms on the top, or in the numerator of our fraction. So I'm going to start with looking for exponent of 2. I see x squared minus x squared. Those guys are going to cancel right out. I see a bunch of terms that just have x's, so I'm going to use my calculator here to keep everything straight. I have a negative 5x. I'm adding 10 more. Here's a negative 5, so I'm going to subtract 5 and a minus 5 again, which gives me negative 5x. Okay, just number-wise, so constants, I have negative 50 and negative 25. So negative 50 minus 25 gives me negative 75. And this is all over x plus 5, x minus 5. This is how we want you to leave your final answer. The numerator should be in standard form, so no parentheses. I know they have, like both of these could be divided by negative 5, take out the GCF. We don't need you to do that. Just keep this numerator in standard form. Denominator should be your LCM. Okay, let's go through another one together. So number 1 gives me 4z over z minus 4, z plus 4, z minus 1. Again, I'm noticing that I do not have anything here that can factor, so I can jump right away to finding my LCM. On the left, I have z minus 4 in the denominator, so I definitely need z minus 4 in my LCM. In this denominator, I had z plus 1, so I'll stick that in the LCM as well. Okay, we didn't give you very much room here, so I would make sure you start all the way on the left on this side. I'm going to rewrite that first fraction. I'm putting that z minus 4 in parentheses since it's a binomial. Okay, I'm comparing this denominator to my LCM. It looks like it's missing the z plus 1, so we'll go ahead and multiply numerator and denominator by z plus 1. Okay, the next one I'm rewriting. It has z plus 1, but it does not have the z minus 4, so we'll go ahead and multiply this one by z minus 4. I'm going to do that on the top and the bottom. Again, these two now have common denominators, so I can write this as just one big old fraction. I'm combining the numerators using that addition. And this is over just our LCM, so the z minus 4, z plus 1. Okay, again, let's go ahead and simplify on the top. So looking at this one, this 4z is going to distribute into these parentheses. 4z times z gives me 4z squared. 4z times 1 is just 4z. Two parentheses right next to each other, so we're distributing again. Z times z gives me z squared. Z times negative 4 is negative 4z. 4 times z is a positive 4z. And positive 4 times negative 4, negative 16. All that craziness is your numerator. Your denominator is still your LCM. Okay, our last and final step here is to combine any like terms in the numerator. So I'm starting with exponent of 2. I see 4z squared plus z squared, so that will give me 5z squared. 4z minus 4z plus 4z. Well, some of those z's are going to cancel out, right? A negative 4 plus 4 cancels, so I just have 4z. And constants, looks like I just have that negative 16. Again, my denominator remains the same, that LCM. This right here is our final answer. Now I do want to do number 2 with you as well. This one's a little bit tricky. When you look at these two denominators, hopefully you're noticing they look very, very similar, right? They look almost the same, like n minus 9, 9 minus n, basically the same thing. What's actually happening here is your expression is the same terms, but opposite signs. So here I have a positive n, here a negative n. Here a negative 9, here a positive 9. So if this happens, what we want to do is factor out a negative 1. So I'm going to look at this second denominator, and what I'm going to do is take out a negative 1 from the 9 and the negative n. That's going to make this 9 negative. I'm going to put that afterwards. And a negative n divided by a negative will make this a positive n. So I really have a negative 1 and then n minus 9. Right, hopefully you notice now the denominators are almost the same, right? The only thing that they have in common that's different is this one has a negative and this one does not. So when I go to find my LCM for this guy, I only need to write that n minus 9 one time. Least common multiple or least common denominator means I want the smallest number of things needed. I only need that n minus 9 once. Now because this denominator has a negative 1, I do want to make sure that I include that negative 1 in my LCM. Now this first fraction, when I rewrite it, it looks like it almost matches the LCM. The only difference is it does not have that negative. So we're going to go ahead and multiply the numerator and denominator by that negative 1. Rewriting my second fraction, I have negative 1 and n minus 9, negative 1 and n minus 9, that it already matches, so I don't have to do any work there. Now that my denominators are the same, we can rewrite this. I'm going to move this negative 1 out front and then put the 2 minus 5n, just because we usually put just that number first. Then I can put my plus 4n minus 5. This is all over my LCM. Again, simplifying on the top here, distributing that negative 1. So negative 1 times 2 gives me negative 2. Negative 1 times negative 5n makes this a positive 5n. Nothing to distribute on that side, so we're going to leave that 4n and negative 5 the same. I'm still over my LCM. We did not give you guys very much room on this one. Alright, we're almost done here. Just combining like terms. On the top, I have 5n plus 4n, which gives me 9n. Negative 2 minus 5 gives me negative 7. And you guessed it, this is still over my LCM. Okay, this process is going to stay the same for every single add and subtract problem that we do. You always want to find your LCM, multiply by whatever was missing, combine your fractions so they have the same denominator, and then simplify in the numerator. The only way that we can make this a little bit harder is to give you more complex denominators where we might have to factor first. Let's go ahead and look at page 11 to see a few examples like that. Alright, example 2 says to simplify, it gives me 4 over x plus 3 plus x minus 7 over x squared plus x minus 6. Now I know the first thing that I should be doing is looking for that LCM, but before I look for the LCM, I want to see if I can factor any of the denominators. Now x plus 3 looks good to go. There's nothing I can factor out. I can't do my whole a times c nonsense because it's only a binomial. So instead I'm going to look at this x squared plus x minus 6. That's a trinomial, so this is where we're going to factor using our a times c. I'm going to do just some side work here, put my factoring blanks. A times c, so 1 times negative 6 gives me negative 6. In the middle is a positive 1. So I need to find two numbers that multiply the negative 6 but add to positive 1. Hopefully you found 3 and negative 2. Alright, now since this a value was 1, we can jump right to our factors, so I'm just going to put these right underneath this and cross this guy off. One of my factors will be x plus 3, the other factor will be x minus 2. Now that the denominator is factored, we can go ahead and list our LCM. Now in my first fraction, the denominator was x plus 3. I want to make sure I put that in my LCM. I don't know why I wrote a 5, that should be a 3. I'm sorry guys. Alright, the second denominator has x plus 3. I already have it in my LCM, so I do not want to write it again. Once it's in there once, that's all we need. But it also has an x minus 2, so I'm going to add on that x minus 2 in my LCM. Same process as we saw with the last few examples. We'll rewrite that first fraction and compare the denominator to the LCM. It looks like it has the x plus 3, that part matches, but I am missing the x minus 2. So I'm going to multiply numerator and denominator by x minus 2. Rewriting the second fraction. Comparing my denominator to my LCM. Looks like it matches already, so I don't have to do any multiplying here. Looking quickly at these two denominators, hopefully we notice they are the same, so we can combine this into one big fraction. I'm going to write my first numerator. We're adding, so I'm going to add the x minus 7. And my common denominator, or LCM, was x plus 3, x minus 2. Simplifying on the top, I should start with distributing this 4. So I have 4x, 4 times negative 2 is negative 8. Nothing to distribute over here, so I'm just going to leave the plus x and minus 7. This is still all over x plus 3, x minus 2. Okay, we are almost there. Combining like terms on top, 4x plus 1 more gives me 5x. Negative 8 minus 7 gives me negative 15. And my denominator is still x plus 3, x minus 2. This right here, my final answer. My denominator matches that LCM. My numerator is in standard form. Okay, we're going to go a little bit out of order here. We're going to skip to number 4. This factoring is a little bit trickier here with number 4, that 2x squared minus 3x minus 5. The 2x minus 5 won't factor at all, but I know I'm going to need to do kind of some trickery factoring here with that a value of 2. So off to the side, maybe a little bit up top here, I'm going to write that trinomial. So the 2x squared minus 3x minus 5. Okay, my factoring blanks. A times c will give me negative 10, adding to the b value, which is negative 3. Okay, hopefully you found those numbers to be negative 5 and 2. Those two will multiply to negative 10 and add to 3. But here's the hard part. That a value is not 1, it's a 2 this time, so we're going to have to do our good old factor by grouping. So I have 2x squared minus 5x plus the 2x, just splitting that middle term using the numbers we found, grouping the first two and the last two. Out of 2x squared and negative 5x, I can't take anything out of the numbers 2 and 5, but they both have an x in common, so I'm going to go ahead and take that x out. I'm left with 2x minus 5. 2x and minus 5, I can't take anything out, but technically there's a little plus 1 out front. You're factoring out a positive 1, which doesn't change anything. My common factor there is 2x minus 5. The next factor is x plus 1. So this denominator here is factoring to 2x minus 5 and x plus 1. Once it's factored, we can go ahead and find our LCM. My first fraction had 2x minus 5, so I want to make sure I have that. My second fraction has 2x minus 5 again. I already have it written, so I don't need to write it again. But it also has x plus 1, so I'm going to include that in my LCM. By rewriting that first fraction, comparing this 2x minus 5 to my LCM, I have that 2x minus 5, but I don't have x plus 1. I'm going to add that, multiplying by the top and the bottom. Another subtraction problem here, so I'm going to change this to a plus sign and change the numerator signs as well. So this positive x squared will become a negative x squared. The positive 9 will become negative 9. Comparing that denominator to my LCM, looks like it already matches. So I don't have to multiply by anything, it's already good to go. I'm noticing these two fractions again have the same denominator, so we can combine them. I have x plus 8 times x plus 1 on the top, plus a negative x squared minus 9 over my LCM of 2x minus 5 and x plus 1. I again want to simplify the numerator. Two parentheses right next to each other being multiplied, so we're going to distribute. X times x gives me x squared. X times 1 is 1x. 8 times x is 8x. 8 times 1 is 8. I have this plus sign and then these parentheses here, so technically you could think about this as distributing a positive 1. That's going to keep that negative x squared and negative 9 the same. Again, this is over 2x minus 5 and x plus 1. Again, combining like terms on the top here, x squared minus x, that cancels out. X-wise, I have plus x plus 8, so 9 x's in total. Positive 8 minus 9 gives me negative 1, and this is all over my LCM. Okay, since we're getting long on time here, we're going to skip number 3. The only thing that I do want to point out is that this denominator can be factored. This is a difference of squares, so the square root of x would give you x's in both parentheses. Square root of 16 would be 4. Remember, there's a minus sign in one parenthesis, a plus sign in the other. So do watch out for those difference of squares. You will see them. But we've seen 5 examples now, which I think should be pretty good.